Hi guys, welcome back from the ad break. I hope you are a bit refreshed. Now we're gonna compare a rhombus with a square and with the other two shapes. Now, guys, if you look at what we did with the first two shapes, right, which is a parallelogram and a rectangle, we looked at what are the similarities, right? Because the parallelogram is like the umbrella, I promise you, with these special kinds of quadrilaterals that we're going to look at. But now, we found that there are similarities between it and a rectangle. But what that therefore means is we will then need, the next layer will be to find what makes the rectangle to be different from a parallelogram, right? So that I can classify them, because then what will be the need for me to say parallelogram, rectangle, rhombus, and a square if I can just call all of them parallelograms? It is because of that one or two or three different properties between these two particular shapes. And then also because of the similarities, we know we can classify them all under the fact that they are a parallelogram. But let's just try and investigate whether a rhombus can also be considered as a parallelogram and a square can it also be considered as a parallelogram. So now, what are the properties of a rhombus? And that's the first question that we're going to ask ourselves, right? And we're going to explore that. Then from there, the second question that we're going to ask ourselves is, based on those properties, can I then classify it as a parallelogram, classify it as a rectangle, or even classify it as a square? And why will I be able to do that based on what I would have tried to answer with those properties there? Now, if we have a rhombus, what we know about a rhombus is both pairs of opposite sides are parallel. That's the very first thing, right? So my blue and my blue, so those will be parallel and opposite, and that one there will be parallel and opposite. Also, we know that those pairs that we have, they are also equal to each other, making this to be equals to that and making this to be equals to that there. Then the other interesting thing about this is opposite angles are equal. Guys, hang on. Are we not talking about properties of a parallelogram here? Because it's like I'm still repeating properties of a parallelogram, right? That's the interesting thing that I want you to please see. Also, the diagonals bisect each other. So as a result, the golden conclusion is that all of these properties are of a parallelogram. But then, why do we call it a rhombus and not a parallelogram? And that's because of the following reasons that we're going to state. So to answer the first question, the properties, we've stated them, but they are incomplete because we still need to say, why is it now a rhombus and not a parallelogram, right? Because I gave it or rather mathematicians gave it a different name from a parallelogram. But we know that it is also a parallelogram, right? So it is under a parallelogram, but why did we call it a rhombus? Now, those are the other properties that we need to look at that made us to call it a rhombus. The very first one is that all sides are equal. So this is a very interesting fact, right? Now, with this, I want you to think about something, right? When we started looking at shapes at the very early grades of mathematics, you know, a square is something that we used to see. It's a cube, right? A cube is made up of a lot of squares and all of that. And what is a square? All the sides are equal, right? So now, we just said all the properties, all the sides of a rhombus are also equal. So do you now see there's now an overlap that goes into a square, which we're going to try and talk about later on. In simple terms, this is what I want you to see. A rhombus will now be, if I straighten it, what will it give me? I want you to think about that while we are trying to talk about this, right? I have a rhombus. It is more or less like, you know, a bit tired. You know, when a person is tired, if they stand up right, which is you straightening it, what shape will it be? Think about that while we are trying to go through this. Now, another property is that the diagonals bisect each other now at right angles. So they don't just bisect each other, but they bisect each other making 90-degree angles while they are bisecting each other there. So that's one very special property that we have there. And then the diagonals bisect the angles. What angles are these? The diagonal will bisect the angles on either side of the diagonal, making this angle to be equal to that angle, this angle to be equal to angle. But hang on, I was told that if I was to call this A, call that B, call this C, call this D, I was told that A is equals to C. So what does that mean? It means A1 and A2 are equal, together with C1 and C2 are also equal. But does this not make 4 equal angles? It does, because this will be X, 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 X. You see, if I was to try and talk about it in terms of X. Now, with all that being said, it means that we can now try and look at a rhombus to be classified as one. It has opposite sides that are parallel. It has opposite sides that are equal. It has opposite angles that are equal. It also has diagonals that bisect each other. But what was very interesting about it was that all the sides were now equal, and the diagonals were bisecting each other at 90 degrees. So that's why it is overlapping, and not only do we consider it as a parallelogram, we make it a specific parallelogram. Now, what are the properties of a square? Also, is a square considered to be a parallelogram, a rectangle, or even a rhombus for that matter? Now, if we have a square, what we know is that both pairs of opposite sides are parallel. So I will have this to be parallel to that, and then I will have this to be parallel to that. Then both of these pairs are also equal to each other. Hence, this will be equals to that, and then this here will be equals to that. Both of the opposite angles in terms of the pairs are also equal, making this here to be equals to that there, and making this to be equal to that there, right? So you can see, I am busy mentioning this, but I'm now thinking, is this not even the same properties of a parallelogram that I'm supposed to know? It might be. So let's see what last property we have. The diagonals bisect each other. No, hang on, man. These are just the properties of a parallelogram. But why do we then call this a square? Let's think about that. Firstly, we know that all these properties that we've spoken about, they make it to also be considered as a parallelogram. So I will start by saying all the properties of a parallelogram hold, but now the most interesting thing here is that the diagonals are equal. Also, the angles are equal, and they are equal to 90 degrees. What does that do? It now introduces the fact that this is a special type of a parallelogram. It is a parallelogram that is a rectangle. But why? So what do we then say? Is a square a parallelogram, a rectangle, or a rhombus? We can actually say a square is a rectangle. Why? Because now that it does have the properties of a parallelogram, when we add a few other properties, it now overlaps to being a rectangle. So it makes it now a rectangle, other than it being a parallelogram. So if we have a square, it means that all the properties of a parallelogram hold, all the properties of a rectangle hold, But now the interesting thing that we need to add now also is, if both the properties of a parallelogram and a rectangle hold, what must I call it now? Because, all right, it's a parallelogram, but there's some properties that are short there. I must add them. It gives me a rectangle. Now I'm thinking, all right, what are the other properties? The other properties are that all sides are equal. Ching ching, now we are thinking rhombus. All right, the diagonals bisected right angles. Rhombus again. The diagonals bisect the angles. This is a rhombus. So it means all the properties of a rhombus also do what? Hold in this particular shape. So now this is a very interesting type of a quadrilateral, because all three quadrilaterals that we've mentioned, they hold in a square. So a square can be a parallelogram, can be a rectangle, can also be a rhombus. But why do we call it a square then? And I'm conflicted now. What do I call it between these three things? Because now I can label it as three things. Let's continue and see exactly. Now, all properties of a parallelogram are true. That's nice. Rectangle, true. Okay. Rhombus, true. So as a result, that makes a square to now overlap in all of them. You see, firstly, a square can be a parallelogram because it has opposite sides parallel, opposite sides equal, opposite angles equal, and the diagonals bisect each other. But in that, I also know that the sides are equal. I also know that the diagonals bisect at 90 degrees. Lastly, I also know that these angles that are equal, they are also 90 degrees. Also, the diagonals are also equal. So, hey, this means a square is now protruding, or rather overlapping, in all the properties that we have here. So, as a result, what do we classify a square is? We can classify a square as a rectangle, as a rhombus, or as a parallelogram, based on the fact that it overlaps in all of them. But we call it a square. Why? Because it's special. It has all of the above properties to be true. And that's how you classify these four quadrilaterals of mine. And I chose them because they have so much in common with one another, which makes them very, very special quadrilaterals. And that's how you then look at which quadrilateral is which and how do you classify them based on the differences in those particular quadrilaterals. All right, guys, we've come to the end of what we need to do for now, but I want us to take a quick ad break, because when we come back, we're going to look at some more problems and some more information that has to do with these quadrilaterals. Please stay tuned. I'll be back just now.